the use of drones in geotechnical investigations. Welcome back to Blueprint to Reality, the channel where civil engineering concepts turn into real-world solutions. From soil and foundations to modern construction technology, we break down engineering ideas in a simple and practical way. Today's topic brings together geotechnical engineering and cutting-edge technology. Introduction. Before any structure is built, engineers must understand the ground beneath it. Geotechnical investigations help determine whether soil and rock conditions are safe for foundations, roads, slopes, and embankments. Traditionally, these investigations rely on field visits, boreholes, and manual surveys. But today, drones, also known as unmanned aerial vehicles, UAVs, are transforming how geotechnical data is collected. In this video, we'll explore what drones are and how they work, why they're used in geotechnical engineering, key applications of drones, types of data collected, in future trends in drone-based investigations. 1. What are drones in geotechnical engineering? Drones are remotely operated or autonomous flying devices equipped with cameras and sensors. In geotechnical investigations, drones are used to capture high-resolution images, create 3D terrain models, monitor ground movement, inspect inaccessible or hazardous sites. They provide aerial perspectives that are difficult, dangerous, or expensive to obtain using traditional methods. 2. Why use drones in geotechnical investigations? Drones offer several advantages over conventional techniques. Rapid data collection over large areas improves safety by reducing field exposure, high accuracy and repeatability costs, and time efficiency access to difficult terrain such as steep slopes and landslide zones. For preliminary investigations, drones are now an essential engineering tool. 3. Types of drones and sensors used. Different geotechnical tasks require different drone systems. A. Multi-rotor drones. Ideal for small areas and detailed inspections, can hover and maneuver precisely. B. Fixed-wing drones. Suitable for large-scale surveys, longer flight time, and higher coverage. Common sensors used. RGB cameras for visual inspection, LiDAR for precise elevation and terrain mapping, thermal cameras for moisture detection, multispectral sensors for soil and vegetation analysis. Each sensor provides valuable data for understanding ground conditions. 4. Applications of drones in geotechnical investigations. Site reconnaissance. Drones quickly assess terrain, drainage patterns, and surface features before detailed ground investigation begins. Slope stability and landslide monitoring. They help identify cracks, movement zones, and changes in slope geometry over time. Earthwork volume calculation. Drones generate accurate cut-and-fill volume estimates for embankments and excavations. Foundation and excavation inspection. Drones safely inspect deep excavations, retaining structures and foundation pits. Road and embankment monitoring. Used to detect settlement, erosion, and deformation in road projects. 5. Data processing and outputs. Drone data is processed using specialized software to create orthophotos, digital elevation models, DM, digital terrain models, DTM, 3D point clouds, contour maps. These outputs help engineers make informed design and construction decisions. 6. Limitations and challenges. Despite their advantages, drones have limitations. Weather dependency, limited battery life, regulatory restrictions. Need for skilled operators cannot replace boreholes or lab testing. Drones complement, not replace, traditional geotechnical investigations. 7. Future of drones in geotechnical engineering. The future includes AI-based data analysis, autonomous drone missions, real-time ground monitoring, integration with BM and GIS systems. Drones will play a key role in smart and digital construction practices. Conclusion. Drones have revolutionized geotechnical investigations by making them safer, faster, more accurate, more cost-effective. When combined with traditional soil and rock testing, drones provide engineers with a complete understanding of site conditions. In modern geotechnical engineering, drones are no longer optional. They are a necessity. If this video added value to your learning, like, share, and subscribe to Blueprint to Reality for more civil and geotechnical engineering content. Have questions or ideas for future videos? Drop them in the comments below. Remember, Great structures begin with understanding the ground beneath them. See you in the next video. Helicopter triangular ruler.